Hello everybody. Today I will discuss about continental drift. So what is continental drift? How the continents are drifting from each other? What are the causes of continental drift? That I will discuss. The first order relief features of the Earth's crust are the continents and the ocean basins. And these continents and ocean basins are not uniformly distributed over the Earth's surface. These features show some puzzling facts which are interpreted in terms of unification of all land masses as one unit in the past, and now they have been separated through rifting and drifting. What are these puzzling facts? These facts are all land masses are mostly concentrated in northern hemisphere. Most of the oceans are located in the southern hemisphere. The continents have their tapering end towards the south side. The North Pole is represented by an ocean, that is Arctic Ocean, and South Pole is occupied by the one major continent, that is Antarctica. And the coastlines of few continents show jigs of feet boundary. For example, east coast of South America and west coast of Africa. So these facts point towards the fact that the continents were united as one unit in the past, and the present distribution of the continents has been due to drifting. This concept is described under continental drift. So this explains the concept of continental drift. So we will discuss about this continental drift. The pioneer workers who gave this concept are Francis Bacon in 1620, Antonio Schneider Pellegrini in 1858, Edward Suez in 19th century, F.B. Taylor in 1908, Alfred Wegener in 1910 to 12, Alexander Duterte 1937. Among these pioneer workers, F.B. Taylor and Wegener are considered to have done a great deal of work to explain the fact that the continents of the world were united in the past, and now they have been dismembered and drifted to their present position by continental drift. To explain this fact, they have cited many examples, and on the basis of those examples, they gave the concept that the continents that we see today, they were united in the past and they have suffered drifting from each other with passage of time. So let us discuss what were their views, particularly the views of Taylor and Wegener. So let us first discuss about the views of Taylor, F.B. Taylor's hypothesis. So according to Taylor, there are two land masses in the past. They are Laurasia, that is existing in the northern hemisphere, and another, that is Gondwana land, which existed in the southern hemisphere. In course of time, these continents started moving towards equator radially from the polar regions, particularly during the Mesozoic or early tertiary time. Through this process, the tertiary mountains of the world, such as Alpine Himalayan mountain chains, Rockies and the Andes mountains, they have evolved. The reason for this drift of the continents from the polar regions to the equator are the following. According to Taylor, the gravitational attraction of the sun and moon on the earth caused this drifting of continents from the pole to the equator. Another factor is that the increase in tidal forces on the earth because of the attraction of sun and moon, and this rise in tidal forces is reflected through the drifting of the continents from the pole towards the equator. Thus, as a consequence of the above attraction of sun and moon over the earth, the rotational speed of the earth increased, which dragged the continents from the polar region towards the equator. The above incident took place in the beginning of the Tertiary era. This view of Taylor was not accepted on following grounds. How tidal force can cause increase in the rotational speed of the earth? It is not possible. How South America drifted westwards after separation from Africa? How the orogenies occurred before the Tertiary period? Because according to Taylor, the Tertiary mountains have been produced because of the equatorward motion of the continents from the polar regions. So, what about the other orogenies which have existed on the Earth's surface? So, that has not been accounted for by Taylor's these hypotheses. So, this hypothesis was not accepted. At that time when he proposed it, he could not give full proof to his hypothesis, that's why it is not accepted. Then Wagner, he studied the paleoclimatic conditions of the continents and came forward with the conclusion that the continents were united in the past and now they have been drifted. So let us discuss what is the views of the Wagner. According to Wagner, the continents occurred as standing blocks floating in form of a layer, that is shell or silicon aluminum rocks, over the underlying viscous layer, that is sima or silicon magnesium rocks. Till the end of Carboniferous or Permian period, the continents were united to form a single landmass, that is Pangaea. So, up to the end of Paleozoic, there was a single landmass, Pangaea. Pangaea means, pan means all, then land. All land or all earth, which are surrounded by one paleo ocean. Panthalassa, pan means all, or entire, thalassa means ocean, water. So, there is one single landmass, that is Pangaea, and it was surrounded by one ancient ocean, that is Panthalassa. This landmass was spread over the two hemispheres of the earth. During Jurassic period, this landmass underwent rifting to form two landmasses, namely northern continent represented by Laurasia or Angara land, and the southern continent represented as Gondwana land. Between these two land masses, a sea came into existence, which is known as Tethys. Further, with passage of time, these two continents suffer drifting and subsequent drifting westward and equatorward to account for the present distribution of the continents. He described this passage of continents as perlflucht or flight from the poles, and he cited many causes to account for the drifting of the continents. So according to him, the gravitational attraction of the sun and moon on earth had led to the rise in tidal forces, which ultimately got reflected in the increase in the rotational speed of the earth, and because of which this drifting could be possible. The other point is that spin of the earth's axis of rotation, which caused the centrifugal forces to operate on the earth, and due to these centrifugal forces there occurred a equatorial bulging of the earth's mass, and because of this bulging, gravitational sliding of the continents took place towards the equator. So these are the two major causes that was cited by Wagner, and also he opined that there might be thermal convection below the continents that might have caused the rise of hot rocks below the continents and sinking of the cold rocks beneath the oceans. By this process, the Americas drifted to give rise to the mountains on their western margins or the western border, and the African land masses and Indian land masses drifted towards north and equator to produce the alpine Himalayan chain of mountains. But his views, all these views were not accepted because he could not cite sufficient reason for the points that he cited. In order to support his views on continental drift, he cited a number of evidences relating to the following aspects, such as variation of climate in the past, occurrence of identical fossils in separated parts of the earth, identical geological structures in separated continents, occurrence and distribution of mountains. So he cited the evidences on these points, on the paleoclimate, on the fossils, on the distribution of the geological structures of the continents, and on the distribution of mountains. But he could not cite good reason so that his views were not accepted at the time when he proposed his views. However, these two workers, Taylor and Wagner, they made a contribution towards the fact that the continents that we see, the oceans that we see, they are not permanent features. They have changed their position with time, and their views got support subsequently when the Paleomagnetism were studied in the ocean basins, and it was thought that the oceans are expanding, ocean floors are expanding. That means oceans and continents that we see today, they are not permanent features, they change their position with time. Wagner, in order to support his views, he cited many examples on climate, on structure, on rock types, on distribution of mountains, and following are some of the evidences which were proposed by Wagner. So let us discuss these evidences. First is the geometrical evidence. The Atlantic coasts of South America and Africa have roughly a jigsaw feet boundary. They fit well in absence of the Atlantic Ocean. But it can be said as a matter of coincidence, because coastlines are not permanent features. They are subjected to change with time due to their interaction with the waves, tides of the ocean or seas. Therefore, survey was conducted at the continental slope region in order to know whether this matching of the west coast of Africa and the east coast of South America, whether they actually match or not. For that, the continental slope region up to a depth of 1000 meter depth was surveyed, and it was found that the boundaries of these two continents, they match. Hence, it is concluded that in the past Africa and South America were together, and now they have been separated by drifting. Similar cases are found between Europe and Africa, which are together in absence of the Red Sea and the Gulf of Aden. Africa, Antarctica, India and Australia are also found to match when they were joined together by 1000 meter contour. There are local gaps and overlaps, but broadly speaking, their coastlines show matching. These facts point to the fact that the continents were united in the past. So, the matching of the boundaries of the continents speak the fact that these continents, southern continents, were united. Also, the North America and the Eurasian continents were together. It has been proved on the basis of their matching of the boundaries. So if we take into account the single landmass Pangaea, this is the single landmass Pangaea. It is surrounded by one ancient ocean, that is Panthalassa. North America, Europe, South America, Africa, India and Antarctica, Australia, they were all together. And in between this Europe and Africa, a small sea was existing, that is Tethys. So there are other evidences which has been cited by Wagner. These are the geological evidences, such as the fold mountains, the orogenic belts, the fold mountain belts of Appalachian of North America, that is towards the east coast of North America, and the west coast of Eurasian continent. They show the fold mountains. These are the Caledonian fold mountains, which match with the Appalachian mountains, and that clearly proves the fact that the North America was united with the Eurasian landmass. Because of which the Caledonian mountains and the Appalachian mountains, they show same types of rock type and the folded mountains. So we have the North European mountains such as Scotland, Scandinavia. They form the Caledonian fold mountains. They match with the Appalachian fold mountains. So matching of the fold mountains prove the fact that the continents were united in the past. Similarly, the orogenic belts, orogenic trends in Ghana and Accra. In Ghana, near Accra, Ghana is the country. So near Accra, Western Africa, there is a clear boundary between 2000 million year old Proterozoic rock with Paleozoic rock, which is 400 million years old. And this boundary runs into the Atlantic Ocean in the southwest direction and is found in Brazil at São Luís. But the rock types of both ages occur, Proterozoic and Paleozoic. Thus, the matching of orogenic trend along with the rock types across the Atlantic Ocean at Ghana and Brazil clearly provide the proof that Ghana and Brazil, they were united, because of which the tectonic trend of the mountains, tectonic trend of the rock types, they match. The boundary between Proterozoic rock and Paleozoic rock exist, and the same trend is found in both the continents, in African west coast and in the east coast of Brazil. So these indicate the fact that these continents were united in the past. So matching of the tectonic trends, matching of the fold mountains, matching of the rock types, all indicate that the continents were united in the past. For rock types, what are rock types which show matching? if we take into account the Mesozoic dolerites, these are found to extend through South Africa, Antarctica and Tasmania. Similarly, Precambrian anorthosites show approximate linear trend through Africa, Madagascar and India. The Precambrian rocks of Central Africa, Madagascar, South India, Brazil and Australia, they show similarity. So, with respect to rock types and their continuity across these oceans, across Atlantic and Indian Ocean, it proves the fact that the southern continents were united in the past. Similarly, other evidences are also cited by Wagner, that is on stratigraphic succession. Distinctive stratigraphic sequence of Permo-Carboniferous stellites overlain by thick continental sedimentary sequences containing Glossopteris flora, Gangampteris flora, which are the plant fossils, and coal beds. These are found to be covered by Mesozoic lava flows, and these sequence of rock types are found in South America, Africa, Antarctica, India and Australia. So this is a sequence of beds. Sequence contains Permo-Carboniferous stellites, which are the glacial deposits. They are overlain by continental sedimentary rocks, which contains the Glossopteris and Gangampteris flora, and they are subsequently they are deposited there. They are overlain by the coal beds, and over the coal beds the Mesozoic lavas occur. That means if this is the sequence, and if the sequence is found in southern continents, in South America, Africa, Antarctica, India and Australia, that clearly proves the fact that these continents were forming one single landmass in the past. The stellites of Talcher, that is Odisha, Pagoda, that is Antarctica, Duica of South Africa, Tubarão of Brazil, they show similarity. So these facts point to their unification as one single landmass in the past. So stratigraphic sequence, they prove that the continents were united in the past. Besides this, we have the metallogenic provinces. There are regions which contain manganese, iron, gold, tin, and these deposits, these mineral deposits, they are found to extend across the oceans within the southern continents. They match across the coastlines of southern continents. That means these continents were united in the past. Similarly, coal deposits are of tropical origin, but such deposits are found in the Antarctica, a country located at the South Pole, where we do not find the tropical climatic condition. It is polar climatic condition. In polar climatic condition, we cannot expect the formation of coal. So when coal is being traced in Antarctica, this clearly proves the fact that Antarctica was in the past nearer the equator, and now it has drifted to the polar regions. So this indicates drifting. And in the past, the continents were united. Similarly, Wagner cited the proof of paleoclimate. The climatic condition of a region is controlled by its latitude, altitude, nearness to the sea, oceanic currents, and wind direction. Broadly speaking, latitude controls the climate. For example, polar region, there is cold or glacial climate. Tropics, it is a humid tropical climate. So the stressing of the paleoclimates of the continents provided a sense with respect to the fact that the north-south drift of continents have taken place. In order to prove it, he cited some of the deposits. For example, glacial deposit. All the continents of southern hemisphere, that is the Gondwana land, they show Permo-Carboniferous glacial deposit. During Permo-Carboniferous time, the climate was glacial, and these continents, they show glacial features, glacial deposits. If it is to be assumed that the glacial deposits have been formed in all the present continents of the Gondwana land, it would mean a glacial climate to prevail over the entire globe, because we see the present day continents to be distributed over the entire southern hemisphere. And if we imagine that the glacial deposits have been formed in all these southern continents, that means entire southern hemisphere is having glacial climate. That means the whole earth is covered under glacial climate. But there is no evidence of glacial deposit in the Laurasian continent. Hence, it is concluded that during Permo-Carboniferous time only, the southern continents were united. They were not distributed in the present manner as we see the continent today. They were united near the South Pole, and the northern continent was near the equator. So these glacial deposits, they indicate the fact that the southern continent was nearer to the South Pole. The glacial striations in rock beds, glacial till, or moraines, they provide evidence that the southern continents were united near the South Pole, having the glaciers over them. Besides these, Wagner cited other examples of deposits such as desert deposit, then carbonate and reef deposits, evaporite deposit, bauxite and laterite deposit, red beds, phosphorites. So these are the different types of deposits which are noted for their climatic relation. In deserts, we have the warm environment, the dune bedding of the desert sandstones can be used to infer the ancient direction of prevailing wind in the deserts. Comparison of this ancient wind direction with the modern wind systems found in the present latitudes can indicate if the continents have undergone any kind of rotation. So in the deserts we have the sand dunes. They have imprinted over them the direction of prevailing wind. Desertic deposits. And at the present day we have the wind circulation. So this wind direction of the deserts has been compared with the modern wind systems, and if they match, then it's okay, but they do not match. That means there has been rotation of the continents or drifting of the continents. So which has been proved from the study of the ancient direction of prevailing wind imprinted over the sandstones or the dunes, sand dunes. Similarly, carbonate reef deposit, they are found to develop within 30 degrees of equator. The continents, southern continents which present these deposits, they are not found within this range. That's why it is proved that the continents have suffered drifting. Similarly, evaporite deposit, it is found within in a arid climatic condition within 10 degree 50 degree latitude condition. Present distribution of these evaporite deposits, if they do not occur within this latitude range, that means the evaporite deposits indicate that the continents have drifted. Similarly, bauxite laterites which develop in subtropical zones by subaerial chemical weathering. So the distribution of these rock types or mineral deposits, if they do not conform to these tropical zones, then they indicate the fact that the continents have drifted. So similarly, red beds and phosphorites, they indicate that the continents have drifted. Besides these, we have the paleontological evidences. The fossils of middle Mesozoic and earlier to that show a good deal of similarity on southern continents of Gondwana land, and this similarity afterwards. So that means up to middle Mesozoic, these southern continents were together, because of which the fossils, they show similarity. And subsequently, after middle Mesozoic, the continents have suffered drifting. So the similarity of fossils, they prove that the continents of Gondwana land have drifted. The similarity of fossil finds is taken as evidence for continental drift on following assumptions. What are the assumptions? There is no contemporary evolution of animals and plants of the same species in different parts of the world. This is one assumption. Land-dwelling animals cannot cross wide oceans. That means oceans are barriers for the migration of the organisms. Based upon these two assumptions, the fossil evidences were correlated to find out if the continents were united together or they were separated as they are seen now. So following are the evidences of fossils that indicate that continents were united together and they have drifted. Fossils of tetrapods indicate the existence of one single landmass in the past. Similarly, Mesosaurus, a freshwater reptile of lower Permian time, occurs as fossils in South Africa and Brazil. This Mesosaurus is a freshwater reptile. It cannot exist in oceanic water. It is a freshwater reptile. This animal is a good swimmer, but it cannot be able to cross 5,000 kilometers of long ocean between Africa and South America, so that its fossil can be expected in both the continents. Thus, these two continents were united in the past, because we find Mesosaurus fossils in South America and Africa. So, South America and Africa were together in the past. As it is a freshwater reptile, it cannot thrive in the oceanic water. It cannot cross such a big distance from South America to Africa, so that its fossil can be traced in both the continents. So, this proves the fact that the continents were united in the past. Similarly, Triassic reptile fossils of Listosaurus, Cyanoganthus are found in Antarctica, South America, Africa, India and China. So that means they were forming landmass which were united together in the past. Similarly, the distribution of trilobites of Cambrian time suggests the unification of the continents. The similarity between the ammonitic fossils found in India, Madagascar and Africa indicate that only shallow seas could have existed between these regions during Jurassic time. It is said that during Jurassic time the Pangaea broke into two supercontinents, that is Laurasia and Gondwana land. Shallow sea was existing. The Gondwana plant fossils such as Glossopteris, Gongopteris found in Gondwana continents, they indicate the location of these continents near the South Pole, because these parts grow in cold climate. They belong to Permo-Carboniferous time. So during Permo-Carboniferous time, Gondwana continent was near the South Pole. And the Laurasian continents, the fossils of Laurasian continent, their varied tropical flora existed in the southeast coast of North America, southwest part of the Europe and northwest end of the Africa. So that means the Laurasian continents, that is North America, Eurasia and north part of Africa, they were together. So these are some of the evidences of fossil that has been cited by Wagner, and they prove that the continents were together in the past. Besides these, the paleomagnetic studies, they clearly indicate that the continents have moved from their original position to the present position. Let us discuss how magnetism or how paleomagnetism helps to indicate the fact that the continents were together and now they have drifted. So magnetic minerals such as magnetite, they form from magma when the magmatism takes place over the land masses. And these magnetic minerals, they try to get aligned along the Earth's magnetic field. Similarly, during sedimentation, the magnetic minerals also get aligned along the Earth's magnetic field. So by study of these magnetic minerals, their orientation, their inclination or their depth, it has been proved that the continents have drifted. By the presence of these magnetic minerals or their magnetic inclinations, study of the magnetic inclinations, direction of magnetic poles and declination, which are recorded in the rock bodies, because rock masses or the continental masses, they contain these minerals. So these magnetic facts are recorded in the rocks that contain the magnetic minerals, and the properties that these minerals, magnetic minerals, show that account for the drifting of the continents. Following mathematical relation is used to locate the latitude of occurrence of the magnetic minerals and not the longitude. Tan of I is equal to 2 tan L, where I is the angle of inclination of the magnetic mineral and L is the latitude of the earth. So this is the graph. 0 degree equator. So on both sides we have this I and this is the graph. Here it is the latitude, here it is the value of Y. So 0 degree latitude shows 0 degree inclination. With increase in latitude, the deep angle increases. So this fact has been utilized to say what is the latitude of a continental mass. What are the latitudinal position of a continental mass in the past and what has been now. From the analysis of this latitudinal data presented by the magnetic minerals, it has been proved that the continents have drifted in different directions. For example, magnetic minerals showing inclination or deep amount 90 degree it indicates the occurrence of a continent near the pole. If it is 0 degree, then the continent is located at the equator, and these data of inclination are locked in the rocks of the continents. If a continent is showing 0 degree inclination of its magnetic minerals, but it is found at the pole, that means it was near the equator when the magnetic mineral was being produced, and now this landmass has drifted from the equator to the pole. Similarly, if the magnetic minerals showing 90 degree dip in a country is found to be located near the equator, that means this landmass has drifted from the pole to the equator. So from the value of the deep data of the magnetic minerals, we can be sure with regard to the latitudinal position of a continent. The following diagram can indicate how the magnetic poles show polar wandering. So this is the landmass. It contains the magnetic minerals oriented like this, magnetic mineral oriented like this, magnetic minerals oriented like this. If you correlate these three magnetic minerals, they will indicate that here is the pole, here is the magnetic pole. This is the pre-drift position, pole is here, and after drifting the pole is found to be here. The magnetic minerals, they are locked within the landmass. Landmass is shifting, landmass is drifting. So the magnetic minerals are changing their direction. So here the direction is towards this side, here the direction is towards this side. That means this pole has shifted to this position or to this position. Actually, the magnetic pole of the earth is not found to be shifting. Similarly, the geographical poles, they are not found to be shifting generally. So this direction of the magnetic minerals, which indicate that pole is here, that means poles are found to be shifted, but it is not actually the shifting of the poles, it is the shifting of the continents from their original place to different locations through drifting. So here it is to be remembered that the Earth's geographical pole is fixed, and near it is located the Earth's magnetic pole. There occurs reversal of magnetic poles. North pole becomes south and south pole becomes north with time. And also the magnetic pole changes location, circular variation related to long-term change in Earth's geodynamo. The point on the Earth's surface where magnetic fields point vertically downward, it is the north magnetic pole. Similarly, if the magnetic field points vertically upward, it locates the south magnetic pole. Rocks of different ages in the same region show slightly different pole positions. When arranged globally, this creates an apparent polar wander path, which actually reflects continental drift rather than the pole drift. So, these magnetic minerals, by virtue of their magnetic data, magnetic inclination, magnetic declination, they prove that the continents were united in the past, and present distribution of the continents has been possible due to drifting. The present day oceans provide stripes of magnetic normal and magnetic reversal minerals in newly created oceanic crust at mid-oceanic ridges. These magnetic poles explain the fact that ocean floors are expanding and the land masses are shifting their geographical location with time. So this accounts for the drifting of the continents. It is seen that the Atlantic Ocean is expanding. The MOR, mid-Atlantic ridge, is expanding and shifting the ocean floor on both sides. Similarly, the Pacific Ocean is found to be contracting. That means oceans, they are not permanent features. Continents that we see in their present position, that is not the fixed position of the continents. So continents have drifted, oceans have been created, oceans have been closed with passage of time. So the views of Wagner that the continents have drifted, that is true. But actually the continents do not drift, but the lithospheric plates which contain the continents, they actually drift, and the drifting of continents has been proved nowadays on the basis of the theory of plate tectonics. So plate tectonics is now explained. Now the plate tectonics explains how the continents have drifted throughout the history of the Earth's evolution. So let us discuss the modern views of the plate tectonics to explain continental drift. So before the discovery of sea floor spreading, it was thought that the continents have actually drifted. But the continents and the ocean basins are the overlying parts of the lithosphere which float over the underlying weak ductile asthenosphere. So lithosphere is the rigid body which contains the continents and which contains the oceans, and these lithospheres are floating over the weak asthenosphere. This lithosphere has been broken into pieces in response to convection current mechanism that operates beneath the lithosphere, and this convection current has actually driven the plates, and the plates have moved, they have converged or they have diverged from each other, they have slided past each other, forming different types of plate boundaries. And these lithospheric plates, they may be entirely oceanic, entirely continental, or mixture of continent and ocean. Thus the continents which are proved to have drifted are actually the parts of the plates that move slowly with respect to one another through the motion of the plates, lithospheric plates. The continents can be called as mere passengers sitting on the moving trains of the lithospheric plates that carry them through their motion. This explains the causes of continental drift. So, the continents, they are the parts of the lithosphere. Oceans, they are the parts of the lithosphere. Continents, so accordingly we have the lithosphere made up of continents only, or made up of oceans only, or it is made up of ocean and continents together. So, when the plates move, they carry with them these continents. So, it is the plate motion that explains the drifting of the continents. This is the diagram that shows how Indian landmass has shifted its position from Cambrian to present. It has moved like this. So, if we think how rifting and unification of continents have taken place in the past, this diagram clearly explains this fact. In the past, land masses were together to form single land mass, let us say supercontinent. It underwent rifting. So two land masses were created, 1, 2, 3, 4, 1, 2, 3, 4. So this is one land mass, this is another land mass. They rifted and drifted. One is drifted like this, the other drifted along this direction. This drifting continues for certain period of time. Then, in between these drifted continents, the oceans come into being. Oceans become old, oceans undergo subsidence, and that leads to convergence of the drifted continents towards each other. So, first drifting, then divergence of the continents, then convergence of continents together to form suturing of the continents, and through suturing another supercontinents results through suturing. So this is the mechanism of the formation of continents and the breaking of continents that has taken place throughout the geologic time, and the entire earth history shows several phases of this unification of continents and breaking. And the last single continent was the Pangaea, and that has been dismembered to Laurasia and Gondwana land. Again, Laurasia has broken to the northern continents, and Gondwana land has been rifted to produce southern continents. Let us see the sequence of events that has actually occurred to account for the drifting of the continents. $200 billion years back, Pangaea was existing as a single continent. It is surrounded by ancient ocean, that is Panthalassa. And a narrow sea was existing between Africa and Eurasia, that is Tethys. Then below 200 million years ago, during the Triassic time, the rift formed in the supercontinent Pangaea to form two continents, Laurasia and Gondwana. At 180 million years ago, that is at the end of Triassic, following events took place. Laurasia got separated from Gondwana. Central Atlantic Ocean was created as North America got separated from Africa. That is, North Africa drifted westwards, Africa drifted eastward. So between them, the Central Atlantic Ocean came into existence. And the Tethys Sea started contracting. The Y-shaped rift formed in the southern Pangaea or in the Gondwana land, which separated Antarctica, Australia from Africa and South America. This got separated from Africa and South America by this Y-shaped rift. India drifted northwards and Indian Ocean was created. At 135 million years ago, that is by the end of Jurassic, South America broke from Africa. It produced the South Atlantic Ocean. The Central Atlantic and Indian Ocean widened. Tethys continued to contract. At 65 million years ago, that is at the close of Cretaceous period, Madagascar got separated from Africa, from east coast of Africa. South Atlantic widened further. Tethys contracted further. Inland Mediterranean Sea was produced out of the Tethys, because Tethys contracted and closed. So, less than 65 billion years ago, that is at the beginning of the Tertiary era, Laurasia faced fragmentation. Rift between Europe and Greenland developed. North Atlantic Ocean completely opened. Labrador, Newfoundland separated from Europe. They drifted to southwest. Greenland was left behind. So Greenland is at its own place. It has not been drifted. Africa collided with Eurasia to form alpine mountains. India collided with Asia to produce Himalayan mountain chain. That is near about 50 million years ago. And 30 million years ago, the East African rifting produced Red Sea between Africa and our Arab continent. Arab drifted northeast to collide with Eurasia to form Zagros Mountains. So these are the major events that have actually taken place in the past and that account for the present distribution of the continents and the oceans. So this is all about the continental drift.